Hello friends, welcome my video classroom. Friends, today I teach instantaneous velocity. First of all, we understand what is instantaneous velocity. Friends, suppose now we have one car and we drive it. So at different position is velocity is different. Okay, so at any point now we want to find out what is velocity of our car. So we need instantaneous velocity. Look here, the average velocity tell us how fast an object has been moving over a given time interval, but does not tell us how fast it moves at different instant of time during the interval. For this, we define instantaneous velocity. Okay? Friends, velocity at an instant is defined as the limit of average velocity. As the time interval, it is denoted by delta t, become infinitesimally small. In other words, here we can write down in mathematical step v is equal to limit delta t tends to 0. Here, meaning of limit delta t tends to 0 means time is very small. Time is not 0, but it is very close to the 0. And here delta x is a displacement and delta t is equal to time interval. So suppose now we want to remove limit delta t tends to 0. So this delta is converted in d. So we can write down v is equal to dx upon dt. Means here we can say that x is changed with respect to time. It is denoted by x dot, means one time of derivative x with respect to time. Okay. The language of calculus, it is the differential coefficient of x with respect to t and is denoted by v is equal to dx upon dt. Okay. Friends, now we have two types of method to find instantaneous velocity. First is a graphical method and second is a by numerical method. So first of all we understand by graphical method. Friends, first of all we calculate different time and its distance. Suppose here below given x versus t graph is for non-uniform motion of car and we want to obtain graphically the value of velocity at time t is equal to 4 seconds. First of all, on y-axis now we take a distance and on x-axis now we take time. And now we draw a graph like this. Okay. So friend, first of all, now we want to find out distance between P1 and P2. Here P1 is equal to 2 and P2 is equal to 10. So between them, displacement, it is denoted by delta x. and respective time is delta t1. After, now we want to find out distance between q1 and q2. It is denoted by delta x 2 and respective time it is denoted by delta t2. Next, we can find out distance between t1 and t2. It is denoted by delta x3 and respected time is delta t3. After, at point P, we can find out what is the instantaneous velocity. So at that point now we draw a slope and we can calculate instantaneous velocity. Friends, suppose by keeping t is equal to 4 seconds in mind, if we take different time interval delta t1, delta t2, delta t3, dash dash dash, then for this time interval displacement will be p1 p2, q1 q2, t1 t2, dash dash dash, and corresponding displacement are delta x1, delta x2 and delta x3. In all this time interval, the average velocity comes near to some exact value, and when the time interval becomes 0, it means limit delta t tends to 0. At time average velocity gives instantaneous velocity at t is equal to 4 seconds. It is difficult to use graphical method always. Slope of the graph is instantaneous velocity at the point. Slope is equal to tan theta. And with the help of the value of 10, we can find out slope. And slope is a instantaneous velocity at that point. For the motion is straight line, the slope is constant. Hence the average and instantaneous velocity are same. Second method is numerical method. In this method, now we calculate time and displacement and we find out instantaneous velocity. Look here. Here now we have one formula, x is equal to 0.08 t cube. Here table gives the value of delta x upon delta t calculated for delta t equal to 2 second, 1 second, 0.5 second, 0.1 second and 0.01 second. Centered at t is equal to 4 seconds. The second and third column gives the value of t1. This is the second column is t1, third column is a t2. So here t1 is equal to, now we have formula t minus delta t by 2 and t2 is equal to t plus delta t by 2. And the fourth and fifth column give the corresponding value of x. Here, this is a x1, this is a x2 and difference between them is a delta x. First of all, here what is the value of x? t1 is equal to 0.08 t1 cube. Here now we have formula x is equal to 0.08 t cube. So for t1 we can write down x t1 is equal to 0.08 t1 cube. And for x t2 0.08 t2 cube. the sixth column lists the difference delta x. Means delta x is equal to xt2 minus xt1. And the last column given the ratio of delta x and delta t. That means the average velocity corresponding to the value of delta x listed in the first column. Okay, so first of all we understand. Look here. Now we take time t1 is equal to 3 seconds and t2 is equal to 5 seconds. And respected time, its displacement is 2.16. And at 5 seconds, expected displacement is equal to 10 meter. So first of all, now we want to find out delta x. Now means xt2 minus xt1. We calculate with the help of calculator. So we get 7.84 delta x. And here 5 minus 3 means difference between time is equal to 2 seconds. So here 7.84 divided by 2. So we get answer 3.92. Same way, when our distance is 3.43 and respected time is equal to 3.5 second and distance 7.29 meter, respected time is equal to 4.5. So we can find out delta t is equal to 1 because 4.5 minus 3.5 is equal to means delta t is equal to 1. But delta x is equal to, now we want to find out, means 7.29 minus 3.43 means 3.86 divided by delta t means delta t is equal to 1. So our answer is 3.86. Same way, now we have respected distance and respected means time and distance both are available. So same way we can find out delta x upon delta t. So here time is nearly 0 but not 0. So we can calculate instantaneous velocity of any vehicle. Look here. Now we have one graph are available. V versus t. In this case, initially velocity is increased, after velocity is constant, and again its speed is continuously, means case velocity is continuously decreased. Look here, for this case the variation of velocity with time is found to be so in the figure. For the figure we note that during the periods t is equal to 0 second to t is equal to 10 second, it is increasing. Look here, 0 to 10 it is increasing. T is equal to 10 to t is equal to 18 second, the velocity is constant. Between period t is equal to 18 second to t is equal to 20 second, it is uniformly decreased and during the period. So friends, today I teach instantaneous velocity. It is very useful in our life. So friends, you prepare this question. Okay.